Talk Shoes. Recorded live.
Hello and welcome to the Virtualization Security Roundtable podcast episode number 87. Our guest panelists today are Eben Rodriguez, who is a cloud security infrastructure architect helping eBay adapt new and use cases to their internal and external managed compute services. Boris Strongland, who is the co-founder and currently VP of Advanced Products at HighTrust with 20 years of experience in software development, enterprise systems, and security. Hopefully joining us soon will be Michael Berman, who is the CTO of Catbird, and myself, Edward Hledke, a.k.a. TechSciWill in the VMware Communities Forums and author of the book, VMware vSphere and Virtual Infrastructure Security, Securing the Virtual Environment. And our special guest panelists this week are Davi Ottenheimer, who's been on here before, and Matt Wallace, and they just came out with a book called Securing the Virtual Environment, How to Defend the Enterprise Against Attack. And this is actually, I got an early copy of this book, and it's a very interesting way of looking at virtualization security. They actually go out of their way to show you some of the attacks that go on. They have lots and lots of nice references, but they also cover more than just VMware products. They cover Zen as well, and I believe you guys have also hit some of the other aspects of, mentioned Hyper-V and KVM in various spots as well. So welcome, Davi and Matt.
Thank you.
Thanks.
It's true, we tried to attack everybody equally.
Yeah, early on, I think we had to make a decision about, targeting specific platforms or trying to deal with virtualization and cloud security more from a philosophical, general, base principle standpoint. And we ended up sort of opting for the latter, which is why we tried to spread the love around with the vulnerability.
So unlike my book, which goes off and is more of an architectural pursuit and tells of the possibility of these threats, you're actually demonstrating those threats in the book.
That's right.
And you're using well-known threats, mostly from, a lot of them it looked like came from Vasto, which we've had some of the people from Vasto on. Is that correct, or did you get some more from some other locations?
I think we only used a couple from them. We definitely used others.
Yeah, I certainly didn't use any particular canonical source. I tried to look for, obviously, each of our chapters is sort of topical. And so we were trying to be thorough and, in addition to what we knew, make sure that we had sort of researched the areas. So if you look at Chapter 5, where we talked about hypervisor vulnerabilities, and part of the research we were doing there, one of the questions we really wanted to answer is, what's the real risk here for hypervisor vulnerabilities? Has this stuff been in the wild? How often was it reported? How often were those reports actually exploited? How quickly were they patched? Questions like that. And along the way, of course, we ran into the KVM hypervisor vulnerability that was presented one year at Black Hat, and I thought that was a sort of canonical exploit where you really could just run arbitrary code, in the hypervisor from the get.
Okay. So when you just said you did a bunch of research on that, what's your opinion? Do you think that the hypervisor cannot be abused?
Well, it clearly can be abused. I mean, that particular exploit there, which the book actually has, an example that if you've got an AMD processor, you can actually compile it yourself, and it's got the Linux headers, so that you can actually build the whole test environment. Now, it was I had to actually include on the DVD with the book the old QEMU package, because you would have to be running something that was outdated, to be vulnerable. But I liked it because it proved in theory, that this is a vulnerability that could have happened in the real world, and had it been discovered by someone who was malicious and wanted to sort of keep it in their toolkit rather than using it. People out there who are building fan. Obviously, Red Hat's a big fan of it for a while. So this could have been more than theoretical. Now, I've never heard of that KVM exploit being actually exploited in the wild. So, that's something that we haven't heard about.
Well, besides that, is it something that Metasploit has an attack for example?
Actually, yes, they do. Vasto has that. So to plug in, if you go look up Vasto, VASTO, on Google, you'll come across the place to download it. And that's a set of, it's a library that can be pulled into Metasploit, and then you can run all the attacks from there.
Right.
As well.
So this is Boris. I just had a question. So I haven't read the book yet, which I'm going to rectify. But if you had to summarize it in a nutshell, could you do like an overall theme or overall conclusions summary?
Sure. I mean, the basic, I guess going back to what Ed was saying there a second ago, the hypervisor can be abused. It's software, it has some hardware, but the bottom line is you're moving into a virtual environment, and you have to learn the attack vectors and the new ways of threats coming at you in order to defend it properly. So the book provides you a list of examples and some thought exercises around the attacks in order to understand the best ways to defend your environment.
And these attacks, are they fundamentally different from, say, attacks on other operating systems or physical servers and so on? Do people need to think fundamentally differently other than saying, well, this is a new attack surface and we just need to protect it, in a similar way? Is there something fundamentally different here?
That's kind of a semantics argument. I mean, some people would say it's fundamentally different. Some people would say it's the same basic fundamentals, but the style is different. So we know for a fact that people are thinking about attacks in the exact same way they have for many centuries. It's not like anything really different is happening here. However, the technology is different, so you can't say being shot with a gun is the same as being killed with a sword. But being attacked with the same mindset. Yeah.
Well, I mean, the other thing is that what does the hypervisor do? In my physical environment, I have all but one of the same attack surfaces. I have networking, I have storage, I have compute and memory. What the hypervisor does is literally give me another layer above the CPU and memory, basically a lower level kernel that could be open to attack if I could get out of the VM. Now, most of the attacks that I see are actually against the management layers more than they are about breaking out of a VM and trying to attack from that.
Well, that's a good point. And I'll never forget some guy at VMware said, yes, VMware is super secure and safe. There's never been any vulnerabilities. And then they were having some sort of argument on the Internet. But he said that the problems are not vulnerabilities, they're configuration issues. And so it comes to architecture and whatnot, like putting your VMs to have access on your management network, it's probably a bad idea, right? And then ESX out of the box doesn't even have a password defined. You have to go in and set it. And so obviously you need to take care of these things. Would you say that
installed without a password? So that's really a good one.
Is there anything you found in the research or writing of the book that indicated that one hypervisor was, say, more secure out of the box than any other, even if it's not just vulnerabilities, but even from a design perspective or architecture type of configuration?
The problem with answering that question is that, yesterday the answer might have been one, and today the answer is a different one because they're changing. It's not like you can ever identify one that's going to be.
There's a mindset that goes into the design of a product. Like everyone remembers that Microsoft got in a lot of trouble because they tried to make their products really easy to use out of the box, and so by default there was a lot of security that was off. And a lot of that shifted now, like Ubuntu, for example, doesn't even ship with an SSH server installed if you want SSH.
Most Linuxes don't anymore.
Right. So there's this whole shift in mindset. I'm wondering if you noticed, from a fundamental philosophy perspective, any kind of differences amongst them, if you could talk to that a little bit.
Well,
yeah, I think we did notice differences.
Interject something?
Yeah,
Davi, before you go on, can I interject one thing?
Go ahead.
So we mentioned the Vasto attacks. I've actually been trying them against ESXi5. and almost all of them, but a few fail outright. So, and that's just a base install, no special in security. So yes, they're getting better. So Davi, your turn.
Well, in the interest of full disclosure, Matt and I both work very closely with VMware, and I actually worked directly on the hardening guide for vSphere 5. So I'm intimately familiar with the security exercise and the level of effort that VMware has put into security. So that obviously colors a lot of my perspective. However, I think we do notice a difference in the different hypervisors, and it does change over time. So to your point on Microsoft, they were very notoriously weak in security, but they invested a lot of resources into becoming more secure. I think their weakness now is their legacy more than where they're going. So, the more they're compatible with older systems. Apple, by comparison, cut bait and just basically said, we're not going to support the old systems anymore, and that has helped them immensely.
Right.
So they can move forward. So I think what we see at VMware is a huge investment in security. The response to the recent breach announcements has been, exceptional. I've been very happy to see how quickly they respond and how seriously they take these issues. I mean, by comparison, if you look at the recent Zen exploit, Intel's response was fascinating because they basically said, to your earlier point, that's a configuration issue. You're talking about a ring 3 to ring 0 exploit, and
right.
Intel's like, that's documented in our development guide. It's the way it's supposed to function. That's not a very impressive response.
But so configuration issues, that's the problem, right? Is the stance on security has been in the past make it easy to use, thus less secure. But has that shifted pretty much across the board? Then is that what I'm hearing? That to be more secure out of the box.
Yeah, I think you'll notice, for example, vSphere 5 has no console. I mean, the ESXi is the only option now, right? So
So SSH and other things are disabled out of the box, right? That's the kind of.
Let's stop that for a second. ESXi has a console. It is a management console. It is a management construct. It is still there. It's a POSIX environment. Yes, it no longer has the GNU Linux environment, but it still is a console. Otherwise, you can't give the thing an IP address.
Right, but I mean, what I'm saying is they've moved away from convenience, obviously, to make it as robust as possible yet secure. So they're getting rid of a lot of the options before that made it even more convenient because it provides a higher level of performance, higher level of security. So
they've eliminated a number of attack vectors.
Fair enough.
They've actually provided inside the management console now is a firewall, as well as some other things that'll keep the well-known attacks from coming in.
What about other vendors? You mentioned Apple. They don't have a hypervisor, do they?
No, they don't provide a virtualization. No.
And so you looked at Zen, like Citrix, for example, and you also looked at. Did you look at Microsoft Hyper-V?
We did look at Hyper-V, but there's not a lot about it specific to it.
Okay. And then what were the other ones on top of that? KVM, did you try it on both Ubuntu and Red Hat? Or were there differences there?
The exploit I believe we just ran it on Ubuntu. Matthew, did you try it on Red Hat?
Matt's not on right now.
No, he's not.
We're waiting for him to dial back in.
Oh, yeah, I think it was done on Ubuntu.
Okay. Because I've kind of participated in some of the marketing side of the Red Hat Hyper-V thing, or what do they call it, Rev, R-H-E-V, and their big thing is security. They claim that they're the most secure, right, with all these SE Linux and other things that you can turn on. But I don't know if they have a hardening guide, so I think that's a good measure. Also, the fact that they reached out to you guys and worked with you on creating the hardening guide is good for VMware. I'm wondering if other vendors have similar configuration or hardening guides for security.
Yeah, I've actually noticed a few companies move. Gentoo actually has a nice XCCDF, and I think that's, again, I'm a little jaded because I'm working on this, but I think that the SCAP standard is the future for a lot of these discussions. Can
you tell me more about that?
It's an automation protocol that's defined by NIST. So it's an open standard, it's a government standard, and it allows you to create these clear text documents. So the XCCDF is your configuration checklist, and you can then specify in an XCCDF file all the checks that you want to do on a system to make sure it's configured properly. So when you say, is this out of the box going to disable SSH, you can just have an XCCDF that you run instantly on a machine and see, is the SSH service on or off. So it gives you visibility, and it's easily modified.
So those configuration templates, different companies might download one and modify it for their needs, right? But do those exist for all the different hypervisors now, or just a few? You mentioned Gentoo. How does that correlate to hypervisor security?
Well, I'm just saying, some people are moving forward with them and publishing them. I didn't see one for Red Hat. They might have one in the works. I don't know, but I noticed one right away.
SCAP
Awesome.
has a huge library of routines. Matter of fact, the CIS security benchmarks are all implemented using XCCDF, which can then be read into OpenSCAP, and you can run it. The problem with SCAP is generally, unless you have a better engine, they have to run locally. The OpenSCAP all runs locally, which means with the hypervisor, you almost want to run them always remotely because you may have thousands.
So how would that work on a ESX host? Would we enable SSH and then run it remotely through SSH keys?
I don't know.
No, you can actually run a tool. They're just starting to come out now, but you could run a tool like VCM. So you've got basically a configuration manager that's supposed to be talking to your hypervisor and your guests as well.
Mm-hmm.
And then you can just run an SCAP engine on VCM. I think it already works, actually.
What's VCM?
VMware Configuration Manager.
Oh.
Matter of fact, the subset of rules that are publicly available are actually XCCDF, I thought.
Well, we just wrote the XCCDF for vSphere 5, and it's actually kind of fun because what you're doing is codifying the hardening guide, which already is in a spreadsheet, which is cool. That's another big change.
Awesome, I see it. Yeah, it's right there on the internet.
We released vSphere 5 as a spreadsheet so people could just use it as a checklist, right? Because before it was a PDF, and then auditors had to convert it.
Thank you very much for that, by the way. I've had a look at the draft, and it's fantastic, having that spreadsheet format.
Yeah, great team working on it. And then, the next step is that we move it into this, it's the extensible configuration checklist description format, just to make it clear, but it's describing the checks that you should do. So it doesn't actually do the checks. The next step is to go into Oval, and then Oval actually runs the checks. So VMware should be releasing soon this clear text XML file that shows you the description of the checks, which is comparable to that spreadsheet, and then the Oval, which allows you to actually run checks using a computer, using a script, using something, some product. And, you can use VCM, which is a product from VMware, but the cool thing is, because it's all XML and it's a standard from NIST, you could also use another product, and you can edit it, and you can give it to your friends or competitors, and you can update and share. People ask a lot, like you asked, how do I make sure this is set up and configured properly for this environment? Well, if you have a PCI configuration, you could publish that. The PCI Standards Council could actually publish an XCCDF that says this is the configuration we expect our auditors to use in these environments.
And the interesting thing about SCAP is that it can even ask you questions instead of saying, "Oh, I can't." There's some things that cannot be electronically checked.
Right. Have you received security training within the last year or something?
Or more along the lines, do you have your SAS 70? Do you know where it is?
Right.
There's all sorts of things. Oval is a huge set of XCCDFs that are interlinked and intermingled. And yes, there are ones for ESX in there already. If you look at the NIST stuff, there's a few there. There's ones for Red Hat. There's one for Zen, KVM. They're all there, but not all of them are kept up to date, and that's the big problem.
Yeah, hopefully that'll change, though, with you have standards-based and clear text. People can easily see the latest version, update it, publish it, release their own.
And are you guys writing in pure XCCDF, or are you writing in more Oval and cross-linking everything?
No. I wrote the XCCDF, and then another team wrote the Oval.
So you got XCCDF, you're the back end, and they wrote all the funny linkage that's in Oval.
Yeah. Oval's more interesting in some sense because it's actually doing that automation of checking the content, checking the list. XCCDF is really just converting that spreadsheet and figuring out ways to organize it into different questions.
And SCAP is
services you want on.
Yeah, allows you to run everything.
Yeah, and SCAP is the security content automation protocol. Right. So I really think there are other standards out there, but I've been a big fan of NIST since the 80s when Reagan basically threw down the line. He was like, the military and the intelligence community shouldn't run our internet. It should be the civilian side. So NIST has really been taking that gauntlet. I don't know if a lot of people remember that, but I still see it that way. So working with NIST is a pleasure for me.
Actually, doesn't MITRE own most of Oval these days?
They do a lot of work on it for sure. They actually publish, I think, a lot of the standards or keep it up to date. But NIST is integrated with them, and there's also a convergence with DMTF and X9. I work on all these different standards bodies. There's just so many of them working in the same space. But I think that if you want to answer the question today, how is this configured? Which is the most secure hypervisor? It's like asking, which is the fastest car? Is it Chevy? Is it Ford? It's kind of like how you've tuned it, how you've written it, and that answer comes from a standard like SCAP because it tells you how it's been tuned, how it's been configured. It gives you a readout and it gives you options, and then you can tweak it, and then you can say, well, this is more secure because we ran this hardening script on this hypervisor, which is more secure than that one.
Now, let me ask you a question from an international perspective. Is there any difference? Do we know if there are organizations that are global that use NIST standards, or do we need something that's more globally centric?
I used to have a different answer to that a while ago,
okay.
But then I was working in China, and I realized that everything they were doing was like NIST says this and NIST says that.
Oh, really?
And I was working in Europe, and people were like, "Have you seen the latest NIST guidelines?"
Okay.
I think people really look to the United States, and in particular NIST, for guidance because they do such a great job publishing really open and really clear technical standards. Not always. They do have some guides. Some of the special publications are kind of high level and just fluff, but some of them are really, line by line. This is how you need to configure your system for it to be more secure. And I think it's international, even though it's a U.S.-based. Like ENICE has been publishing some great stuff in Europe. A European group releasing some interesting stuff about risk and cloud, and everyone in the world using it.
And you guys mentioned MITRE. I know at some of the RSA shows there was a lot of confusion over certain settings, the configuration changes being system management settings or security settings. Has that line been blurred now so that we can say these are security settings versus configuration settings, or should they be the same? Should we not try to differentiate things like that with the checklists and whatnot? Do we need separate security checklists, or can they be configuration checklists?
I think you'll always have something that's going to be security-based. I think security has existed separately. Early in my career, I used to work on security, and people said, "Oh, that's just an offshoot. Why don't you become an IT guy?" I really believe that security has a place because the values you use in security are different. Like we used to say in incident response, I'll give you 24 hours for infrastructure to solve a problem, and after that it becomes a security incident. So you just have a different way of looking at the world, where the risk is, where the values are, and that different mindset means there'll always be questions that are slightly different in either category.
I think of it as like overlapping circles, like a Venn diagram. There are configuration things that are security, configurations, and things that are just user preferences, and vice versa. There are security concerns that are and are not configuration issues. Because in audit, like we're using these tools not to make changes. Like you mentioned VCM, does that make changes to systems also, or does it just audit?
Yeah, I can push changes.
Okay. So that would be a tool that the operations team would use to manage, and they would. How would a security team interact with the ops team to, say, get a report out? Is that something that's pretty easy to do across all your different, platforms? If you're not just using, say, VMware, maybe you've got some, Microsoft stuff and some Oracle and Linux stuff. How can I provide a more consistent view? Are hypervisors getting at the point now where you can bring them into the mainstream from a security audit perspective?
That's a touchy subject. Because every vendor that wants to differentiate will make their advanced features or their upsell incompatible. So yeah, there may be standards that they operate at where they can share, but once you start getting some cool feature functionality, like vMotion, you can't vMotion across non-VMware hypervisor.
Right.
So the answer is yes, you can manage a totally heterogeneous environment.
I guess that's true. And then as like I mentioned, Red Hat, I know their big secret sauce supposedly for security is SE Linux, and that's not something that's going to work on another hypervisor probably.
Right.
Well, that's possible, but we already talked about that when we had Symantec on with the critical solutions protection. But I wouldn't discount SE Linux as a possibility or some sort of multi-layer security yet.
All right.
I mean, I think we're going to eventually get there because I think it's absolutely necessary. How it gets implemented will be the big interesting thing. Now,
I just want to point out that the difference, so this is a good example of where the difference between a security and an infrastructure mindset might come in, where if you have lots of different types of hypervisors, it actually becomes harder to secure because you're trying to patch, especially different versions of different makes of hypervisor. You kind of want to keep things as consistent and simple as possible. So there are a lot of advantages to getting rid of it.
Yeah, I mean, there's more to it than that. Even you have to have expertise to harden all of them. You have to keep up to date with news on all of them.
Yeah.
But it's really not. I mean, when you talk about hardening the hypervisor, that's one thing. But really becomes, to me, it's no longer really good enough to harden the hypervisor. Yes, that's the first step and absolutely should be done. But when I look at it, I think it's a bad scoping problem if that's all we're going to do.
You also have to synchronize the time, right?
Well, besides synchronizing the time, but I'm talking about the entire virtual environment is more than the hypervisor.
Yeah, definitely.
I mean, all management constructs, it's all the storage constructs, it's all the networking constructs.
Right.
And when we put those all together, effectively what we're looking at is hardening a high-performance cluster.
Yeah.
And anytime you harden a high-performance cluster, you slow it down.
We bring that out in the book quite a bit, that there's this entire ecosystem that you have to look at. The hypervisor is a new component of the ecosystem, and it changes the ecosystem, but it's much larger. What you're really hardening is the whole environment.
So I have a question about Hyper-V. Have you worked a lot with Hyper-V? Do you think that the issues there are substantially different from sort of Linux-based hypervisors like ESX and KVM and Zen?
Well, let's put it this way. KVM and Zen are Linux-based. VMware is not. VMware.
Yeah, I suppose, but although initially there was a console OS based on CentOS and ESXi has...
The console is not the hypervisor, but that's a different story.
Sure, but it's part of it, sort of part of the ecosystem. So that's why I'm interested to see, since Microsoft is very different in that respect from everybody else. Do you see a set of different issues there?
Well, I mean, I don't know if it's significantly different. I mean, Hyper-V essentially is similar to 2008, I guess, is the way of looking at it.
Well, Hyper-V is like KVM and Zen. That type of architecture is a parent partition or a parent domain, and then everything funnels through that from the driver's perspective. VMware is really the only one that's different than any of those.
But I guess what I was getting at is that it's using Windows ecosystem and its security features to secure access to the hypervisor itself, to the management plane and so on, right? So it's a different set of tools, different set of components. Wouldn't you agree?
Different than what?
Different than, say, Zen and KVM. I guess VMware, it is in a different category by itself.
So that's a good point. So a lot of organizations use Active Directory for keeping track of the user ID and even rights management, who can do what groups people are in. And it's nice that VMware integrates with that, and of course Microsoft does from Hyper-V. I wonder if the similar types of policies can apply to KVM and Zen. Do I have rights management linked with Active Directory, for example? Or do I need to come up with my own way of doing rights management?
As far as I know, you can. There are plenty of tools to allow a Linux console to use Active Directory. So for me,
is that something that the vendors support out of the box? Was that looked at in the book at all?
Citrix Zen Server does, but I don't think you mentioned that in the book at all, do you?
What was the question? I got lost in the...
Sorry, if along the lines of what Boris was talking about, is that a lot of organizations are using Active Directory to keep track of their users and what the users can and can't do, say like what group they're in. If I'm say an engineer or a system administrator or enterprise admin type of thing, I have different rights as far as what I can do. And I know that since I have personal experience with VMware that it integrates really nicely with Active Directory. And,
lately.
And Microsoft Hyper-V, of course, would also. But as far as ease of integration with the company's existing user database, how does KVM or Zen compare? Did you look at that in the book at all, those kind of operations aspects?
We did talk about that, yeah. We didn't do a direct comparison because the book's really not about trying to make a comparison point about which hypervisor is the most secure. It's more about thinking about issues like that. So we raised it as an issue. You definitely have to have integration with user management. And this comes up all the time. For example, if you want to have a local user account, especially in terms of compliance too. Compliance regulations don't allow you to have generic accounts anymore. So if you want to have that sort of emergency account when something fails, your admin can jump onto the hypervisor and log in and fix it. Is that
sort of a backdoor or something? Yeah, I know what you're talking about. Most organizations have that.
Right, and we're trying to get rid of that. So we're trying to make people think about how that should really be a group policy that's managed centrally. And so when you remove the person from the group, they no longer have access, and they can't come back later, 6 months later, like in the case of Shionogi. They can't VPN 6 months later and delete all of your instances.
Right. And, I mean, there are tools for that, so it's good that you mentioned that because you can put a compensating control in place to handle that.
Yeah.
But you also need to, when you think about identities, you think about the virtual environment and how that works is that every management tool out there, let's say, let's pick on vSphere, then we'll pick on Hyper-V and Zen, but every management tool that's out there, if it's not vCenter, talks to vCenter. And it authenticates against itself or against Active Directory and then uses a delegate user to talk to vCenter, which uses a delegate user to talk to ESX. So when you're looking at ESX or you're looking at vCenter, you actually do not know which user was the one that
right.
Hey, this is the guy that actually made the mistake.
I know what you're talking about.
So from an auditing perspective, you've got to audit way up the stack instead of at the very bottom. And Hyper-V has a similar problem because everything ties in the System Center. I'll use a delegate user to talk to System Center. System Center talks to Hyper-V using its delegate user. All bets are off.
Yeah, that's an excellent point because we've tried to emphasize, and I think this change is actually coming now, but we've really emphasized a unique ID that can be carried across all systems in an ecosystem. It goes back to that ecosystem where, the butterfly flaps its wings and then all these things change through orchestration APIs, management, chargeback, usage meter. They're all talking to each other and you only have a couple points that you can correlate instead of having a unique ID across everything that you just say, show me all events related to this action.
And that particular request has been put into just about every vendor.
Yeah,
but
it's happening.
But every hypervisor vendor, but it goes further than that. If you look at all the add-on tools in the ecosystem that do not come from VMware, do not come from Microsoft, they all do the exact same thing. So it's like every vendor needs to have this type of implementation.
Right.
Have some unique ID that says this is the real user. And unfortunately, that's not part of authentication today.
No, it's not. And at HITRUST, we hear this request all the time. People want to have the complete visibility and traceability, up and down the stack. So, and that becomes really difficult because of all the components in the stack, from top to the bottom to down to storage. By the way, another question I had is do you cover storage at all in the book? Is there anything specifically about storage and storage virtualization that people need to be aware of from a security standpoint?
We absolutely cover storage, yeah. A couple things, hot buttons for me anyway, are the encryption of storage and how that's managed, key management for storage. So, for example, the hypervisor may handle the storage communication, and then the guests are all talking with the shared key on the hypervisor. So it doesn't really protect any of the guests against each other if they wanted to attack each other's stored data.
Mm-hmm.
Yeah, but there's also a little bit of discussion about how, virtual disks tend to get moved around. People do things like maybe automate moving VMs around with OVF tool or whatever, and how some of that stuff happens on network transit. Obviously, it has to be secure to work just in place, whether it's NFS or iSCSI, just talking about segregating storage networks and what sort of tools are available to make sure that, everything is basically separated and, trying to ensure that, especially when you have, a heterogeneous environment, basically that you're not, exposing any holes that would allow user level, tenant virtual machines or other sort of tenant networks to be seeing traffic on storage networks.
But
and
then
I talked a little bit about.
But then you also have the fact that I can tell the hypervisor and tell the hardware to say move that volume to that virtual disk to somewhere else, and it does it in the hardware. So the tracking actually has to be in the hypervisor itself, and I need to know who did that move way down on the storage logs as well.
Yeah, we talk a little bit about backups as well, because there's the concern, obviously, that in any sort of environment like this, there's sort of tendency now to start looking at. People want whole solutions. Like this much I can say for people who are looking at, say, public clouds with service providers. They want a system where people can deal with, backup and recovery, and there's going to be, I think, a trend towards, people looking for specific guarantees about, IPO type of guarantees, and you have to ask if, your provider basically is doing all of your backup, DR, and that'll obviously grow to even be multi-site as well. Who has access to all that data? Davi and I were talking a while back about, a particular audit where he was looking at someone, and it turned out that even though there was this really ironclad security for people directly accessing, tenant volumes, where everything was logged, everything was secure, anybody could basically any ops person at any time could go and pull up basically the archived version of the disk, out of the backup system. And not only was it not really strongly authenticated, it wasn't even logged. So that sort of thing can be overlooked. It doesn't do you a lot of good if you've got this ironclad operational security for the live disk, but basically no security for the backup versions of the volumes.
Yeah, it actually gets even worse when you start talking about storage clouds, where you start and replication receiver clouds, where you're actually replicating or backing up to a cloud. What type of controls do they have?
Yeah, so I try to put it just in simple terms. I try to put or frame it in the context of, okay, you're putting everything into the vault, but then anyone can go in and take it out of the vault. That's kind of the way.
I've got a silly question here. I mean, I don't know. Maybe I've been doing this too long. That sounds like really basic common sense to me. But if we have to tell people that, is that true? I mean,
yeah.
Wow.
Yeah, it is true. I mean, those are real cases, because I'm an assessor and I go on site and I see these things. But it's
not. This book sounds like this book is a great tool because it kind of says things in a general way to get people to think, right?
Yeah.
And I was thinking a lot of the stuff you guys have mentioned is in my CIS, the benchmark we've been working on for CIS for VMware ESX. But, who's going to read that? An auditor who's already pretty savvy about security, or a sysadmin who's already probably thinking about that stuff. But this book sounds like it's a book for the people who are interested in security and deciding, what hypervisors to use and how to back things up and how to design things. But they're not the ones doing it necessarily, but maybe making a lot of decisions about how things are done. So this is good for them, like for my manager, right?
Yeah.
Yeah.
We wanted a broad audience.
We kept the technical content. I mean, the hardcore. We did these very technical examples, that we called hands-on examples too. That I think if you're a manager, of person, probably would just skip completely over them. But then we have all this space where we talk.
But it's there, so they can kind of see the real world. Oh, it's a real world example. But they probably wouldn't read it, or they might skim through it, But it's there, so it's real.
And we went out of our way, too, to make the hands-on examples things that, like, even the average sysadmin with, their Mac or their Linux box that they use every day, we tried to make this stuff where you could grab a couple tools and you could actually be doing this. Things like SSL sniff that are easy to grab and install. We try to set up circumstances so in a real-world environment where there's high-value assets, obviously you have to be assuming that attackers can actually put a lot of effort into this. And we tried to say, if you are not configuring things in a certain way, then look, here's what happens. And it's actually super simple. Like, my favorite thing to pick on throughout the book, and I wrote about it in several chapters, is just how much people take the entire PKI infrastructure for granted. So, you've got guys, obviously, who are sort of specialists. Who's the guy that I'm thinking of whose name is slipping out of my head, Davi, that presents at Black Hat every year on, what was that?
Foxy?
Yeah. Moxie Marlinspike, like the go-to guy basically on, this PKI infrastructure vulnerabilities. And every year he's got, a whole just host of things that pop up where, he's got examples where you can fake certificates. I want to say that certainly I saw him discuss it, but he may have actually been the one who helped come up with the sort of MD5 checksum copying, basically, where you could generate a legitimate cert and do an MD5 collision, basically, to put a legitimate signature on a totally bogus, cert from a different domain. All sorts of crazy stuff like, redirecting people from SSL to HTTP pages that are basically embedded in iframes, so it looks like you're secure, but you're not, using JavaScript vulnerabilities, things like that. And there's this. Anyways, I hit upon that repeatedly. Basically, I have to say, and I don't know if anybody else is like this, but we have all these lab environments that I've always been using, and we don't bother, putting certs on them that are legitimate certs. So I'm as guilty as the next person. I'm completely habituated to clicking that, go ahead and connect, even though you're getting an invalid cert.
And you automatically click ignore next time.
Yeah.
Just to get that out of the way.
And here's the thing, I think you spend so much time dealing with that sort of lab environment where you think that's fine. You have to ask yourself, if you were doing a production environment, would your brain really say to you, hey, this is a big deal that that this has popped up because this is production, that shouldn't be there, or you click it, ignore.
The whole psychology of the thing.
Yeah, it is. It's a big issue. And then there's just, the fact that there are all these, certificate providers all over the world. And so here's the thing. Increasingly, this is one of those highlights of, cloud in general, is all the infrastructure that you're deploying is now API accessible. These are not machines and racks where you need to log into an IPMI interface anymore. And, we have some examples in the book where, we put SSH keys, say, on machines with Cloud Director, or run arbitrary scripts on a VM, through the Cloud Director API, because you can do that just through the guest customization interface. So now we're talking about web calls. So what's securing that? Just your certs. Well, you have stuff like that, Dutch provider of SSL certificates that got completely compromised. And, all the browsers released, obviously, DigiNotar. Obviously, the browsers have released patches to pull that out of that sort of root certificate store. But look at the root certificate store. You've got literally hundreds of, root certificates that you're ultimately trusting, and it's your infrastructure, that is sort of, at risk, basically.
So you need to up the ante now, get more sophisticated, and protect your root certificates and know what they are and where they came from and all that.
Yeah,
the message really is trust, right? So the book, I think, goes on and on about how there are all these different trust relationships you're taking, and you really have to be careful and understand where the trust comes from.
And education is definitely a big part of it, and this is a great idea. I missed the name of the book at the beginning of the show. Could someone put it into the chat window? So
if you scroll up, you should be able to see Mike.
Oh, great. All right, thanks.
There's the Amazon link for it.
I think some people will be getting this book for Christmas.
Yeah, I think I'm going to order one, definitely. Hey, a slightly different subject. So on the subject of templates, security templates and checks, Evan's been doing great work at CIS, issuing standards and standard checklist templates. So, Evan, how does that compare with what's coming out of NIST?
How does the CIS templates compare with NIST?
Right. So the stuff that you're putting out, which is great, and we've definitely used at HITRUST, how does it compare with what's coming out of NIST?
Yeah, it's a little different audience, I think. CIS is very much about consensus based. So I don't go as far as say lowest common denominator, but it's something that's more achievable, for the masses. And NIST is a government standard and have much more resources, and it's, I think, more complicated to achieve, right?
Okay.
I think they both serve very important purposes, and they're very complementary too. So what I find is that we use NIST as a generic standard, and CIS has much more specific standards that we can use. So the CIS standards are benchmarks, really, much more. So we use them as a benchmark.
And we also, I don't know if NIST does a good job of that. In the past, I've seen a lot of kind of generic guidance. But for the CIS, it's very specific with even examples of, what code and the parameters to set and what they should be set to.
Right, and that's what makes it very valuable. But I guess if I were just starting out in security and I wanted to figure out how to secure my infrastructure, I would start with the NIST sort of for the overall view and then drill down into the CIS benchmarks. Would that work?
Yeah, and CIS is definitely good for like auditors to use and sysadmins who have experience with the product. It says things in CIS like go to the advanced settings and enter these two parameters. So if you don't know how to do that, it might not. Usually know how to do that. So a good sysadmin would know that. But then on the NIST, it's very like make sure you're using a strong password, I think is what NIST might say. It doesn't tell you how to do that.
No, actually it does.
They have
there's some that are specific. Yeah, there's some that are specific, but
for SCAP, when you start dealing with XCCDF, SCAP, and OVAL, they actually get very specific.
I think it depends on who writes them.
And you can override them when you do your tests.
And then the other thing is, I can tell you, it just came out from CIS. We are very much taking get the tall trees. Just a few tall trees are better than a whole forest of controls. And so the CCSS is like that. Are you guys familiar with that CCSS?
Yeah, it uses XCCDF actually.
Yeah, so as part of the CIS benchmark, we took the benchmark for VMware ESX and put it into a spreadsheet. And only the most important elements that we looked at, not all of the elements from the benchmark, but the most important ones were put into a spreadsheet with an assigned CCSS score. And they're going to be releasing like a top 10 sort of list along the lines of what SAN says, but more specific to whatever hypervisor or OS is being part of the spreadsheet.
What do you guys, that's actually very good to do. But Davi, Matt, what do you guys think about the latest cloud attacks? Specifically uploading bad VMX files that has been talked about on some of the VMware communities.
Oh, I'd love to talk about that. To me, that's a perfect example of the trust problem. So you have essentially an environment where you're saying we're going to trust the person who has the ability to modify this configuration has to have a certain amount of authority or trust. So if you allow your end users to modify files that are on the server, you're giving them too much trust, essentially. So that should never really be happening. That exploit has a particular vector that people should not allow. It's like saying, you're going to run a server and you're going to allow your users to edit the password file directly. That's a configuration file that they should have to live within and not have direct access to.
I would say that's not a vulnerability. That's a configuration mistake, right?
But shouldn't the cloud, the import mechanism, however it is, let's pick on vSphere here. If I'm going through vCenter, I would expect that the import mechanism's going to verify that the config file is good, and if it isn't, it's going to tell you, sorry, we can't do this.
It does.
Well, I think that was the issue. Was that in this particular exploit, it was something where it required you to actually directly upload the files to the data store without going through vCenter.
Right. You would bypass the import essentially in order to get the exploit to work.
Okay.
So it was pretty well crafted as an exploit that showed how misconfiguration is a bad thing.
It's extremely well crafted. It allowed you, if you did it this way, if you're allowing anybody to directly drop a VMX file, or, for example, if I'm not importing an appliance but just putting the appliance out on the system.
Yeah, but it's at the level of saying, it's like saying, it's a bad idea to have your wireless access point open to the public if you have sensitive files that you don't want people to get.
Yeah. I mean, you guys say, it is an exploit because someone's taking advantage of a bad situation, but it's a configuration issue. It's the choice. Kind of like the clipboard, copy and paste from the clipboard, You got to decide if you want to enable that or not. Do you need that functionality or not, or do you want to take the risk? Do you accept the risk that this functionality allows?
Okay, so I get a appliance from a third-party vendor. It's a product. I've trusted that vendor for years. I've used their products for years. This product has an exploit in it. When I load that VMX file, whatever it is, that VMDK file actually, the meta file for the VMDK, it's crafted to allow the OS direct access to the hypervisor files. That came from a trusted source. They got hacked. Now I'm hacked because I downloaded it because, hey, it's a new version. I always need to keep things up to date according to my security policies. So we've done everything right. But there's no reason why the hypervisor should launch something that has that type of problem in it.
Well, you lost me at when the provider allows that to happen. That's I think you have to be able to choose.
I'm not even talking about a cloud provider. It could be a local virtual environment. It's not just clouds here we're talking about. It's the virtual environment in general.
Yeah, but you have to admit that this is a configuration issue. So there are definitely circumstances where people have poor configurations. But if you just take the minimal steps, it goes back to our checklist. If you set up the box by default, it won't allow this. And if you configure it and pay attention to the configuration, it won't allow this type of attack.
And I have a question about your question, Ed. That data store where the VMDK was installed, is that shared with other machines of the same security, group, or different higher?
It'll make a difference because you can modify the VMDK meta file to say point to Etsy password on the hypervisor. You can modify it to point anywhere on the hypervisor.
But if you have access to the hypervisor, you can also just, directly, you can also just go get those files.
Right.
No, not necessarily. Some files you can't just get unless you can log in. This actually
the data store is open.
The login capability.
Well, it's not even login. You're talking about access to the data store. So if you have access to the data store, you have access to the files.
This is basically bridging the gap here, where if this is the whole scenario is if you have a service provider or some other entity basically that is allowing someone to do an upload and they don't upload they don't verify the integrity of the VMX and VMDKs, then you're essentially effectively giving them access to those system files. So yes, it does mean that you can't just arbitrarily trust a VMDK and VMX, and there's certainly a scenario where you could argue that the VMware hypervisor ought to keep track of what is a system file and not allow access from a VM. You basically should reject the configuration, like even if you put into place a VMX, VMDK that reference the Etsy password or something similar, the dump files that they used for pulling things out of memory, that sort of thing. You could argue that it ought to know what the system files are and not allow them access, but still, if you have some sort of safe upload where it verifies the integrity of the configuration files in the first place, then there's not actually a vulnerability.
And we definitely in the book try to emphasize the big picture. There's an example of this with a provider who's allowing FTP access to push your VMX or VMDK files. And you have to just take a step back and say, wait a minute, you're clear text FTPing, so your password's already gone if anyone's really watching this environment.
Thank you very much.
And even if you're using SSL without pre-shared certificates, your data's already gone anyways.
Yeah.
Somebody already has a copy.
Yeah.
It's all about trust, right, Ed?
Don't trust anybody.
The safest
You don't trust
computer
your
is
mom?
one that's off.
Trust but verify.
Trust but verify.
It all comes back to Reagan.
I think it was Gordon that said it first.
that was actually kind of the call out for the SSL certificates that I brought up. It's, a lot of us are used to using SSH, and we know that, we have to trust and verify the certificate the first time, but it always makes me wonder, why is it that browsers are different? Websites have certificates for a really long time. Couldn't we get, why do browsers not have warnings when this, certificate that you've used in the past that isn't expired suddenly changes to a different certificate? It doesn't strike me as a big ask.
Chrome, I think Chrome now has that if you want to turn it on.
Yeah, that'd be useful. I haven't been using it lately, but
when you think about all that, there needs to be a level of integrity checking across several things, I would think. One would be you need to integrity check that the VMDK, now given all these new exploits, or not this new exploit, but if you don't integrity check your VMDK, VMX files, you get what you may have problems, guaranteed probably. If you do not integrity check your Active Directory authentication as well,
you guys cover
problems.
Integrity checks in your book, like SHA-1 or MD5?
Yeah, we definitely talk about trust, and we talk about taking a step back and making sure the container of, the hypervisor essentially has a container role, and if you're not verifying at the container level, not just the VMDK or the VMX or, but everything. If you're not verifying that your container is sound, then there's a huge risk of somebody punching through the container.
Awesome. That's fantastic. Well, I'm looking forward to checking it out.
Yeah. With the MD5, it's an interesting point on MD5 now, because you have Flame coming out and people talking about this MD5 risk that people were talking about in 2005, 2007, 2009. It seemed like every 2 years, on odd years, there was a huge statement around it. Don't use MD5 anymore. It's not trusted. And in, I think 2007, Debian even came out and said, don't trust the update process because MD5 is broken. So people could use our update process to create a collision, which is exactly the Flame attack vector. So
right.
A lot of this stuff's been around since, time immemorial, it seems like, and people are just implementing it over and over again. And that's what hits the news, is the implementation of it.
So explain that to me in layman's terms. So if I do what Ed said and check the integrity of a file I just downloaded from the internet, and it matches what the vendor says the checksum should be, it's possible, if it was done with MD5, that binary I downloaded is really a rogue infected binary, but the attacker has modified the MD5 checksum. He knows how to attack it so that it's the same as what the vendor had. Is that what you're saying?
Yeah, there are a couple different aspects to it. They could have done it's called a collision, but they could have done collision to get the certificate to look like the real certificate, or they could have gotten the actual binary hash to look the same. Or
assuming that the actual file that the original provider checksummed was legitimate, and you're basically, the attacker is trying to give you a compromised binary with the correct checksum so that you check the compromised binary, then they could do that via collision. Basically, they will make all the modifications they need so the exploit is there, and then they can basically tinker with. What they'll do is they'll pad out the binary with a bunch of effectively white space, knobs or sort of things, and then start tinkering with that in order to produce the collision, basically.
Wow. And so this is real world attack. If I'm the guy that builds, Windows servers or ESX servers or whatever in my environment, and I have this library of ISO files, it's possible that if someone else has access to that library of ISO files, they might have done this attack and changed one of those, right? And if I'm using MD5, I might not be able to tell that they changed it or not. So I should be using another checksum besides MD5 to verify these, right?
Yeah, so this is why the SSL certificates don't use MD5 anymore, because this is how it was, the certificates basically MD5 has, it's blocked, and so, there are blocks with the cipher, and so, there's padding where the block alignment occurs, and with the certificates, this has allowed them basically to generate hash collisions so that they could go and get a certificate for www.foo.com.
Right.
Then they could go generate a certificate for, say, Microsoft.com.
Right.
And what they would do is they would then tamper with all that sort of data that wasn't used in those block alignment boundaries in order to generate a hash collision so that the fake Microsoft certificate had the same checksum as the legitimate certificate, and they just copy the. Then once the checksum matches, now they just take the certificate authority and they can copy the signature over. And since the checksum matches, it now looks like the certificate authority is certifying that that Microsoft certificate was legitimate.
Yeah, awesome.
But just to be clear, though, I mean,
That's awesome,
I don't remember the exact dates, but 2005, MD5 was pretty much done. People said don't use it. In 2007, Bell Labs came out with a report that said software update processes are, at huge risk. So the government, NIST, and everyone else moved away from MD5 around 2007-ish, and then by 2009, there's nobody that should have been using MD5 anymore. So these exploits...
But a lot of vendors still have MD5 checksums on their pages for when you download the software.
Yeah, not just vendors, but, a lot of banks, a lot of financial industry, a lot of people. In fact, I blogged about this a while ago, but the PCI Council backed away from ND5 because they actually made an exception where they said if you're not using it for security, you can still use it. For just infrastructure, it's fine.
But you got to also remember, when I said integrity checks, I wasn't thinking MD5s or SHA-1s or SHA-512s or whatever.
Okay.
I was actually thinking of inspection of the file to ensure that, because in this particular attack, it's actually the VMDK meta file data. And that's easy to read. It's very short. You should be able to inspect it to make sure there's no odd path names in there before you upload the VM. And even while you're doing it, you may want to periodically run a scan against those to say, are these doing odd things?
Or
but just remember, this is also how hot ad works, so you may see things crossing boundaries. But you got to make sure if it is doing that, that it's actually a backup tool and not something else.
Well, so what's interesting, too, about that particular exploit is you have to be doing very, very little verification, right? Because we're talking about, you've got the VMX and you've got the VMDK, and both of them can basically, you've got the VMDK can be referencing the quote-unquote part, basically, or you've got, the VMX referencing a file. But you would think that even if you had your sort of roll your own upload process, you would want the person to upload all the files, and then you'd verify, say, at least that the files they claimed they'd uploaded were there. So, they're going to, be uploading, say, 2 files where you'd be expecting 3 because the third file is the one that they're referencing that's already on the system. You'd essentially have to have an upload process where they're saying there's 3 files. They've only actually uploaded 2 because the third one is off, somewhere on the hypervisor's file system. And I would say not the, VMFS, but the sort of hypervisor system files.
I could see a way around that, too.
In even a directory. So there's a lot of stuff you can do in this, like opening up dev SHM and getting access to shared memory and things like that would be a really bad thing.
But OVF isn't vulnerable, and OVF imports aren't vulnerable. So, OVF is just an easy way of saying, turn off this import process and use the OVF, and you're fine.
Yeah. Exactly, and OVF will strip out anything that's bad or not allow it to happen. So using the OVF is the recommended way for importing new virtual appliances, and it will do all that checking for you.
Well, I would say using a validation process, like you're saying, is the recommended way. And if you're allowing people to directly put their own VMX files, you're not using validation. But if you don't want to figure out how to do it that way, use the way that's already been created for you, which is the OVF import, and that simplifies it.
I think the analogy that we used is, if you are running, say, a shared hosting service and you're allowing people to, say, upload their own .htaccess file or something like that, you obviously need to constrain your server such that they're not allowed to, modify htaccess files so that they can do things that you wouldn't want them to do. You don't just, create a process where they can do whatever they want. And similarly here, if you're going to roll your own upload process, you obviously need to have your own verification, not no verification.
Yep.
Okay. And while we're over our time, unfortunately, Davi, you want to have you and Matt get the last word.
Okay, thanks for having us on. I'm really happy to talk about the the security of the hypervisor, security of the virtual environment. I hope the book is helpful to people. It's, like I say, a mindset that we're trying to create around security that shows people the ways they should think, and then give some examples of real exploits, real-world problems, so they can see the risks.
Yeah, I mean, it's interesting because we had this dilemma, obviously, of, practical versus theoretical, and, I'm nervous that people would wish there was much more. Like, obviously, Edward's book is filled with this, intense advice about exactly how to configure, VMware things securely, which we love, but then, there's not enough space in a book like this to cover that for every hypervisor, and we didn't want to be focused on just one. So, but it seems like this sort of hybrid approach of having, some examples and some theory that people have been warmed to that. So we've been really happy that it's been received reasonably well. And
the next edition will cover cloud more specifically.
Oh, that was my question. What's next for you guys? So that's awesome. Good.
Yeah, big data and cloud.
So say Davi's going to die attempting to write a big data book by his deadline. He won't survive for second edition because of all the work involved.
Maybe disappear into the data.
You will become the big data. Well, gentlemen,
anyway,
thank you very much.
Us. Yeah, thank you.
And everybody, let me. That's it for this episode of the Virtualization Security Podcast. The Securing Virtual Environment Enterprise, Securing the Virtual Environment, How to Defend the Enterprise Against Attack is a book from Davi and Matthew. And I think it's a good read. I think everybody should have it in their library as one of the additional books there. I look forward to anybody else has a book or anybody wants to talk further about this, they can get in touch with Davi and Matthew. And if you need to, you can go through me to get that. Thank you guys for being on the show.
Thank you.
Yeah, thanks again.